Welcome to Math260, lesson number 3. In our first two lessons, we learned about the basic idea of vectors as either geometric objects or in terms of coordinates. We learned how to determine how to add vectors, how to change their length by scaling, and also how to take the dot product of two vectors, which we said indicated both was related at least to their lengths and the angle between them. So we're going to make that very specific today as we look at the vector norm, or length of a vector, and the cosine rule, both of which are closely connected with the dot product. So first let's go back to basic high school trigonometry. Trigonometry is really just the study of triangles. So here's a basic triangle. We'll give it sides as A, B, and C. And you probably remember from high school geometry the relationship between A, B, and C, known by the Greeks, called the Pythagorean theorem, which says that A squared plus B squared is C squared. Or if I have A and B, I can find C as the square root. And so if I look at this as a vector with components, A and B, so here's my vector U, and it has components A and B, or coordinates A and B, then its length must be C. And so we already have a formula now for the length of these vectors in two dimensions. But there's a nice way we can connect this to the dot product. Notice if I take U dot U, where U is this vector with elements A and B, then what do I get? Well, U dot U is A times A plus B times B, the sum of the products of the corresponding elements, or in other words, A squared plus B squared, which is C squared by Pythagoras. So I can define the length of a vector then, at least in two dimensions. The length, or norm, we use double bars around it to indicate we're taking the length, is the square root of U dot U, because that's exactly what the length was. It turns out that this formula will work in any dimension, but we have a little bit of work to prove that. So let's do one example. Suppose my vector U, do a real easy example to start, is the vector with elements 4, 3. Or x coordinate is 4, the y coordinate is 3. And if I compute U dot U, what's it equal to? Well, it's 4 times 4, because I have two copies of U, plus 3 times 3. Well, 4 times 4 is 16, 3 times 3 is 9, 16 plus 9 is 25. And that's my C squared, my length squared. And so the length of U is just the square root of that dot product, U dot U, or the square root of 25, which we know is 5. Okay, so that's the example in 2D, but while we have this picture here, we want to remember a little bit about trigonometry. If I call this angle capital A, and remember our basic trigonometric definitions, I'm going to erase this and then move to the trigonometric definitions. by definition, the sine of this angle, sine of angle A, is the opposite over the hypotenuse. B over C. The cosine of the angle is the adjacent over the hypotenuse. And the tangent of that angle, which is actually the slope of this line, is the ratio, opposite over adjacent. Now, why do we care about this? Well, we're going to be looking at how the dot product is related to the cosine of this angle, or in general, the cosine of the angle between two vectors. So back to the original example, if this is 4, and this side is length 3, this side is length 5, then what would I have for my trigonometric functions? B over C is 3/5. A over C is 4/5. And tangent B over A is 3/4. Okay, so now let's connect. In particular, we're going to focus on the cosine, which is the ratio of the adjacent to the hypotenuse in a triangle. We're going to focus on that and write down what the cosine rule is, and then work with it a little bit. So to find the length of a vector, I take the dot product of the vector with itself. I'm going to now use the dot product between two vectors to write down the formula for this cosine rule for the dot product. So here it is. In general, if I take the dot product of two vectors, it's the product of the lengths. The length of the first one times the length of the second one. And it equals this exactly only when the two vectors go in the same direction. If they're not in the same direction, it's times the cosine of the angle between the vectors. So in pictures, suppose here's my vector u, and here's my vector v. And suppose this angle is 30 degrees by way of example, and this length is 6, and this length is 4, then the dot product of these two vectors, even though I don't know their components, is four times 6, the product of the lengths, times the cosine of 30 degrees. And if you remember from your high school trigonometry, or if not, the sine of 30 degrees is 1/2, the cosine is the square root of 3 over 2. So this is 4 times 6 times the square root of 3 over 2. And the 2's cancel, so I have 2 times 6 is 12 times the square root of 3. So that's the exact value of the dot product of the vectors. It's the length of the first one times the length of the second one times the cosine of the angle between. Now what's this good for? Well, generally, the part that's missing isn't the dot product, because we can compute that easily if we have the coordinates of the vectors. But it's useful to actually find the cosine of the angle. So let's reverse this problem. Look at a new problem where we use this formula, that the dot product is the product of the lengths times the cosine of the angle, to actually find the angle. Let's make up two new vectors. 5 minus 2 is the coordinates of the first one. And 3 comma 4 is the coordinates of the second one. Well, let's compute the lengths first. What's the length of u? Well, it's the square root of the sum of the squares. So it's the square root of 5 squared plus negative 2 squared. And when we square a negative number, we get a positive. So this is 25 plus 4, the square root of 29. And the length of v is the square root of the sum of the squares, so that's the square root of 9 plus 16, that's the square root of 25, so that's 5. Made that one easy. So now by my cosine rule, the dot product is the product of these lengths times the cosine of the angle, but we already know how to compute the dot product. In this case, u dot v is just the sum of the products of the corresponding elements. So it's 5 times 3 plus negative 2 times 4. So that's 15 minus 8, which is 7. So now we can set up our formula. What does it tell us? It tells us that u dot v, 7, is equal to the product of the lengths, 5 times the square root of 29, times the cosine of the angle between. So now we just divide both sides by 5 square roots of 29, and I solve for the cosine. So the cosine of this angle is exactly 7 over 5 times the square root of 29. Now we can use a calculator to turn that into a number, but this is really the gist. Once I know the cosine, I can use a function on the calculator to return the angle. Okay, so that's the vector norm and cosine rule. We'll get lots of practice using this in class.